Hi, this video is going to tell you how to find the value of a trig ratio using a calculator. It's actually super simple. This video might be a little bit longer because I'm first going to tell you a couple of things that you want to look for in your calculator, and then after I show you how to actually find the value of a trig ratio, I kind of talk just a smidge about trig, so you don't have to watch that if you don't want. So let's just start off. The calculator that I'm showing is just kind of one of your primitive scientific calculators, nothing fancy. The reason why I'm actually showing you this is we're finding trig ratios based on degrees of an angle. So if you look at this calculator here, there's that little DEG, and that is what you want for beginning geometry. If you get into upper levels, say Algebra 2 or pre-calculus or anything like that, you would probably turn to radians, and that's a whole different thing. So if you're taking the SATs or any standardized tests, it's always something good to find out, like, will the test be all in degrees? Will it all be in all radians? What do you need to find out? But for this introductory topic, for just like your high school geometry course, we're going to do degrees. What I have here in the second picture is just what I'm pressing, that if I wanted to change it and I didn't want to be in degrees, I would press that button there, the DRG button, and that would change it, and the DEG would change to radians, and it would say RAD. And another option that it might show is GRAD. So any of those are options. On the typical TI-83 calculator, TI-84, I believe that you look for the mode button. Not positive that's it. But if you press one of those buttons, it'll be in one of the menus that are there, and you can change degrees to radians or radians to degrees from that key press. But don't be afraid to press some keys. I think that's it. It's just, again, if you're doing this like in a classroom setting and you're getting negative values for the trig ratios, it usually means you're in radians, and you should be in degrees. So let's do this. So how do you do it? You are going to be using the sine, cosine, and tangent buttons. You just choose the one that they tell you. So above, the problem is to tell me what the sine of 33 is. For this type of TI calculator, I'm actually typing in the 33 first, and then I hit the sine button, and it gives me 0.544639035. The norm is to carry it 4 decimal places. You might be told to round your answer to such and such, but during your computations, when you're doing these, you are going to use it to 4 decimal places. So we have 0.4463. The 3 is not strong enough to bump that 6 up to a 7, so we would just say that it's 0.446. And again, this is your nearest 10,000th place. That's what your 4th place is, your 10,000th place. And again, that's the norm, especially for beginning. Let's see. What else did I want to say? I think that's it. We can just move on to the next one. Cosine of 86. Again, for this calculator, I'm typing in the 86, and then I press the cosine button, and I get 0.069756. So 0.06975. I want to round to this place here, and I have to look at the number right after it. The 5 it is big enough to cause that to round up. So my answer is 0.0698. Okay, so it's just as simple as touching a button. For the TI-83s, TI-84s, I believe, I'm positive actually, you hit the sine button first and then type in 33, then hit enter. You would have hit the cosine button first, type in 86, then hit enter. And for this next problem, tangent of 78 will be the same thing for those upper level calculators. Hit tangent first, type in 78, hit enter. For the smaller ones, and I'm not sure how it is for phone calculators, but if that's what you're using, just try it one way and see what you get. Tangent of 78, it comes out to be 4.70463. This is the boss that kind of determines whether the 6 can stay a 6. Our boss is weak. It's only a 3. The rule of thumb is if it's below 5, it's too weak to make you round up. So we just keep it at 4.7046. And then our last problem, before I kind of talk just a little about where these ratios come from, we're going to do sine of 46.3. And again, you can kind of have any number of degrees here. It's usually between, usually you don't have decimals, but sometimes you can. And usually they go from 0 up to 90. Let's see what that is. So 46.3, and then I'm going to hit the sine button, and I get 0.72296. And again, this is where I'm rounding to. the 6 has enough power to round that kind of the 29 up to the 30. So it's 0.7230 would be my answer for that problem there. That's the gist of it. It's literally just taking a calculator and typing things away. So if you are interested in, I'll just give kind of an overview, not a very formal idea of where this stuff came from. But there are trig ratios that are programmed into our calculators are also generally found in appendices of math textbooks. You can see a chart where they list for one degree, they'll have the sine listed, the cosine listed, and the tangent listed. And there's just this really big chart. And then they'll have for 2 degrees, what is the sine, the cosine, the tangent, for 3 degrees, for 4 degrees, and it goes all the way down to 90 degrees. So where did they get these ratios from, and what the heck are these angle measures from? So all of the trig chart is based on 90-degree angles, a right triangle rather. And so what it would say is that perhaps this here is 1 degree. That means that this has to be 89 degrees because the angles of a triangle have to add up to 180. This guy here, we already know anytime you have a right triangle, that one's 90 degrees. And what they did is they studied that when we have a triangle that has these degrees, no matter how big or how little it is, the sine of 1 degree is always going to be the opposite over the adjacent, the opposite over the hypotenuse. And no matter how big or small that triangle is, as long as it has those 3 angles, you're always going to have this ratio here come out to be 0.0175 roughly. That's just something that they studied and determined, and it was kind of probably a pretty big discovery at the time. If we have a right triangle again, I'm drawing the same orientation, and we know that this here is 30, and we know that this here is 60. If we want to find, say, the cosine of 30, the cosine is always going to be the adjacent over the hypotenuse. So it's the ratio of this side here and this side here. No matter what happens to that, how big or small that triangle is, if it has these 3 angles, your cosine is always, those 2 sides are always going to be in a ratio of 0.8660. This isn't the best explanation, honestly. I know I'm feeling the pressure of trying to keep this short. But it's really just that they drew the triangles, set the angles up, and then measured the ratios of the sides. Then they kept the angles the same, but made the triangle bigger, took the ratio of the sides, it matched. They kept the angles the same, made the triangle even bigger, measured out the sides, took the ratio of the side, they matched. So whenever you keep these angles the same, no matter how big or little you make that triangle, these ratios are going to hold. And I mean, that is really kind of magical. I feel like trig is pretty amazing. I think the way that we tend to, it runs across our lives is in school, where we're kind of forced to learn it and the magic kind of drops out of it. But knowing that the ratios of the sides are always going to be the same, no matter how big or small these figures are, like that's kind of, I just think that's really, really cool. So, all right, well, I hope that this helped a little bit. Have a great day.